Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will learn about ESP or electrical submersible pump design, and we will also perform nodal analysis in an ESP lifted well. All right, so it will be very interesting and also important. We will perform the analysis and the simulation using Prosper software. All right, we are now in Prosper software. Okay, we first go to the section. You can follow me. Fluid, oil, and water, and method black oil. Separator, single stage separator, no emulsion. Disable warning for PVT warning. Use default correlation for water viscosity. Newtonian fluid. Flow type, tubing flow. Well type, producer. And firstly, we will start by having no artificial lift. So for artificial lift method, click none or select none. Later on, we will change this section with electrical submersible pump. All right, that's the game plan. And calculation type, you can leave it as it is. But for the well completion, type case hole, but send control, we select gravel pack. All right, so we will have also gravel pack in our well configuration. Reservoir, inflow type single branch with no gas conning. You can also input your user information consisting company, field, and so on and so forth as per required. And you can input your comments in this section. All right, from here, we can click done. We can now go to PVT section data. We click the next section. All right, I've prepared my data for the fluid parameters or PVT parameters. So I'm just going to copy my data and paste it here. Data copied and paste. All right, so for solution GOR of 800, SCF per STB, oil gravity of 37 API, gas gravity of 0.76, and water salinity of 23,000 ppm, no impurities, H2S, CO2, and nitrogen. And for bubble point pressure, solution GOR, and oil formation volume factor, we can select Glasso. Oil viscosity correlation, we can select BL et al. And actually, we have laboratory data. So we click this one, match data. I will copy my data and paste it here with temperature of 210, bubble point pressure of 3500, PSIG. All right, from here, we can click match. Okay, in this section, we can click match all. All right, the calculation has been completed. PVT matching calculation has been completed. Very quick calculation. And this is the results from bubble point. So pressure versus bubble point. All right, we can also see the quality of the matching using this plot by temperature. All right, calculated data means the correlation results. Match data means our laboratory data. Okay, so we click this one. And let's say we want to see gas oil ratio. All right, so this is the gas oil ratio from the correlation. And we will check the laboratory data. We click this one, gas oil ratio. All right, you can see. So our laboratory data and our correlation results are quite matched, except in this interval. All right, but it doesn't matter. Practically speaking, it is matched. All right, click this one, remove all. Now we want to see oil formation volume factor. This is the simulation or correlation results. And this is our laboratory data. Quite match. And again, except in this interval. Replot. All right, but practically speaking, gain, it's matched. The quality is quite good and acceptable. All right, remove all. Let's see the viscosity of the oil. All right, yeah, we can accept this correlation. This is to check and uncheck. All right. This is the results if we select this one, PBRSBO correlation Glasso and oil viscosity Beal et al. Of course, we can check other correlation if you want, but we can finish now. And you can see also the quality of the matching by looking at this section. Right, we have parameter 1, parameter 2, and standard deviation. Okay. We can also check plot all. All right, it's very interesting. We can see bubble point. All right. So we can see the results from Glasso, Standing, Lassater, Vasquez-Bax, and so on and so forth. And we can say they are quite matched, except if we maximize the plot. We can see here, if we maximize the plot, the results from blue line give us the best match. And this blue line is actually standing correlation results. Right? And what about gas oil ratio? We can maximize in this interval again, or maybe in this part. Okay. Yeah, for gas oil ratio, Glasso gives us the best match, right? The red line is Glasso correlation. What about oil formation volume factor? In this interval, let's see for this part. Yeah, Glasso gives us good results, and also Lassater. Oil viscosity. All right. We can maximize at this part. All right. For viscosity, Beal et al. Correlation gives us good match. So we can select Beal et al. All right. You can also check or use this result, standard deviation result, to select the best correlation to use. All right. So as you can see, Glasso for bubble point, standard deviation is 0. So it's good. Solution GOR 0.579 standard deviation. Oil formation volume factor 0.0012 below bubble point, so it's good. And we will compare it with standing results. Bubble point, okay, 0. Solution GOR, standard deviation is higher than that of Glasso correlation. So we can say that Glasso gives us better match in solution GOR. All right. And standing also, oil formation volume factor will have bigger standard deviation. So it means that Glasso can be considered as the best correlations to be used in our simulation. All right, so it's quite clear now. We will select Glasso equation for PB bubble point, RS solution GOR, and oil formation volume factor BO. And we will still select Beal et al. For oil viscosity. All right, we can click done, done, and done. All right, so we have completed this PVT or fluid parameter section. And now we can move to our inflow or reservoir section. We click this one.